All right, AP Micro students, this is an absolutely necessary thing for me to do because we only have a few days together and then we have a test. So we can't delay a day. So I'm shooting this video to basically just supplement for me not being able to be there. And so if you're looking at a calendar, today would be the 16th. We have class today, and then we have class on the 18th, and then we're supposed to take the test on the 24th. And so that would be a total of basically kind of 3 days together. Last Friday, today Tuesday, and then Thursday, and then test on the 24th. It's a short unit, and most of the kind of concepts we already know. I went through a bunch of stuff on Friday. We didn't take notes on it, so we'll do some of that stuff today. So it should go hopefully relatively quickly, and most of it should make sense as I'm going through some of it on the slides today. So a couple of things to make sure that you put on your calendar, prepare for, is that on the 24th, we have a test scheduled. I'm not sure yet if it's going to be at the end of the class period or the beginning of the class period. So if it's at the end of the class period, we'll spend the first part of the class studying, reviewing, preparing, asking questions, going through examples. I have to check with Mrs. Weiss and see if it works to have it at the end of the 24th. If it feels like we're so tight on time that we need a little bit of extra time, we'll try to move it to the end of the 24th. The other thing to take note of is that on Thursday, I'm trying to preemptively push you to get things done. And so I'm going to give you a grade for having 1, 2, and 3 for the problem set completed. And so after this video today, you should be able to do those things. So you shouldn't have to like teach yourself anything. But I'm looking at it, and you should be able to do problem 1, problem 2, and problem 3, for the problem set, and there's like 5 total, so it puts you more than halfway done. But this is something I want you to do, and I'm going to give you a grade on, so you're actually going to get basically like 2 grades for the problem set, for having 1, 2, and 3 done, and then for having the whole thing completed. It looks like we're going to have most things due on the 24th, and so that would be the rest of the problem set, the review video, and then the review packet. All of those things would be due on the 24th, the same day as the test. All right, so make sure that you're writing some of those things down, that you have that in your mind, and that you are, especially since this is a change, that you're doing these problems right here, 1, 2, and 3 on the problem set for Thursday. All right, so have those things done. So make sure you take a look at those. All right, so I'm gonna do it kind of like you see right here. I'm gonna have all the slides that I need right here, and so you don't miss the slides, and it's not just me scribbling stuff and having it be hard to read. I'm going to utilize the slides that I have so you can see everything just like that. So hopefully this works. If it doesn't, I'll change it up. All right, so we're talking about, last time we met, and some of you were not here, last time we met we said we were talking about labor markets, or really we call it factor markets or resource markets. Okay, so we're going to call it the factor market or resource market. And most of the time we talk about it in the context of labor, but it also could be land and it could be capital as we talk about these markets. But as in any case, we know that a market makes me think of, well, there's a supply for it and there's a demand for it. And so we're going to have this, what we typically think of with a supply and demand curve. It's just now we're talking about it in the context of labor, land, or capital, instead of talking about it as we would talk about products, which we've done in the past. All right, so for those of you that were here last time, we looked at this little graphic, and I just reminded us that we have really the last 5 units been talking about things in the product market. And so things in the product market, if you look at this where it says firms sell, well, that would be the supply of goods, right? And if you look down here where it says households buy, that would be demand for goods. And so typically, again, we call this firms, and this would be basically like us, right? And we did a bunch of stuff with that, right? So we did the supply of a good and the demand for a good and the price of a good and the quantity of a good. And we're talking about products in that context, right? So this is the product market. But then we have to ask ourselves kind of two questions. How do businesses create the products? How do they generate those products? And how do individuals, how do households get the money to buy those products? Well, those sorts of exchanges take place up here. So this unit that we're talking about right now, unit 5, which is the unit we're on, is the factor market, or again, one more time, you will also see resource market. And the roles are basically reversed. So if you kind of compare this right here where firms sell, households buy, to this up here, now it's households that are selling something and firms that are buying. Well, what is it? What do I sell? Well, in this context, we sell our labor. Or again, we sell land and capital. Those resources, right, are factors of production. Well, who's doing the buying? Well, the firm is doing the buying of those things, right? So firms are going to buy from us. They're going to buy or demand labor, all right? And so just like in the product market, we had a supply and demand, so too in the factor market, there's going to be a supply of labor and demand for labor. It's just now the suppliers are the households, or us, and the demanders are the firms. So again, the roles are sort of reversed. And so we'll talk about this equilibrium price and quantity for labor. And again, most of the time when we talk about equilibrium price for labor, we talk about it in the context of, if you look right here, those would be wages. And so the wage is set by the supply of workers and the demand for workers in the factor market. And then what happens is those exchanges in the products still take place, right? So people get paid for their work in the form of wages. They take those wages and they buy stuff in the product market. Okay, so if we move over to our next slide, we did this on Friday. We talked about this example. I'm not going to do the same example again since we spent a bunch of time on it on Friday, but I kind of gave us an example, and what we did with this example right here is we figured out how this whole system works. So we use this example to basically derive this idea of the value that a worker generates based upon hiring to make paper chains. And again, we did this example in class. So if you're unsure of that example, or if you want to see that example, you might want to ask somebody that was actually in class last week. So I'm going to move to the next slide. So we'll kind of move on to stuff that we need. All right, so on this slide, it just talks about those things that we should be at least relatively familiar with, or terms that we're relatively familiar with. And so the terms that I want to make sure I point out are the terms physical capital and human capital. Those things are parts of the factors of production, and they help determine basically this idea of income, or the distribution of income. We'll talk about how the demand for different factors basically leads to this distribution of income. And so I think we use LeBron James as an example for one. And so if LeBron James, if there's a huge demand for LeBron James, well, his the amount of revenue that he generates is going to be very high, and so therefore he's going to get paid a lot. And again, we'll talk about that in the future. But we'll go through each one of these details as we go through. So if you look at the kind of examples that we have right here, just kind of simple examples, but and you ask the question, what determines their pay? Most of the time, people don't know. They just say, well, the business or the firm that hires them determines their pay. Not exactly. They might be able to pick the number, but if they had their choice, they'd probably pick the lowest possible number. Why don't they just pay people a minimum wage, right? So do you think all these people get paid minimum wage? If not, why not? Why do they not get paid minimum wage? Why would anybody get paid higher than minimum wage? And so what we want to make sure that we keep in mind is the determinants of somebody's pay have a lot to do with how much revenue they can generate. And so at the kind of the base core of what we're really talking about is that wages and the quantity of workers hired within a certain market, those things are determined by the supply of those workers and the demand of those workers, right? So what if I work in an industry in which the supply is really limited? It's very difficult to become whatever that job is. Let's say lawyer, for example. What do I have to do to become a lawyer? Well, I got to pass the bar exam. I got to go to school for a long, extended period of time, pay a bunch of money to try and become a lawyer. So it's very difficult. Not anybody can just show up one day and become a lawyer. So the supply is going to be very restricted. And a lot of times there's a really big demand for lawyers because, well, in the United States, people like to sue each other a lot. Laws are complex. It's important to have good lawyers, and so the demand is going to be really high. So what does that mean about the pay of a lawyer? Well, if the supply is very limited, the demand is very high, that means their pay is going to be very high. All right, in class I used the example of LeBron James, right? What's the supply of LeBron James? Well, really it's like one. And what's the demand for LeBron James? That's very high, right? So if the supply is very low and the demand is very high, he can command a very, very high wage. What about if you look on the other side of things, like working at McDonald's, right? So how many people are qualified to work a job at McDonald's? Well, almost everybody. If you're 16 years and older, basically anybody that's 16 and older can work the job at McDonald's, right? And so the supply is very, very, very high for that job. And so you can find almost anybody to fill that role. And so you don't have to pay the workers a whole lot of money because you have an extremely high supply of those workers. So this chapter or unit is ultimately about the determinants of pay or wages. Okay, so again, this slide just kind of points out the things that I just said about how labor has a supply and demand like all markets. And so if we look at kind of just an analysis of this for a second, this isn't anything that's too complex or too difficult for us. But we've just got done talking about how this is the supply of workers. This is really individuals, remember, supplying their work. And this is demand. This is firms demanding work. So just as a kind of a quick recap or quick review, if the wage is really high, what's going to be greater, the people that want to work or the people that want to hire? Well, at a very high wage, right, if you dot over and you hit a curve, that's the demand curve. And so businesses don't want to hire that many people at a really high wage, but lots and lots and lots of people want to work at a really high wage, right? So you're going to have 1,000 people wanting to work and only 2,000 jobs available because firms don't want to hire that many people at a really high wage, right? So then you see the kind of opposite of that at a really low wage. So you can see equilibrium on this graphic at about $5 or so, right about here, right? So we'd have an equilibrium wage right there, an equilibrium quantity right there. That stuff just goes way back to basic supply and demand. It's just that this is the supply of individuals and this is demand. This is the supply of work by individuals and this is demand for workers by firms. Now, minimum wage, remember, is a price floor set by the government. So if the government says that $5 is too low of a wage, right? That's not fair. You can't pay people that low of a wage, the government says. And so you have to set this price floor at, we'll call it $7.25, right? So this becomes the new wage in this market. Well, if nothing else changes, if the supply curve doesn't change and the demand curve doesn't change, then a higher minimum wage or a minimum wage set higher than the equilibrium wage is going to have some effects, right? So if this is the new price floor, the minimum wage, let's use a different color. If we dot over and hit a curve, just like we were showing before, there's going to be, let's say, 300 jobs available because 300 firms want to hire 300 workers at the 725 compared to the 500 that they wanted to hire before, and then the quantity supplied is going to be 700. So obviously more people want to work, but what it's going to result in is only 300 people being hired as opposed to the 500 people that were hired before. And so if you continue all else equal, like saying no other changes take place, if you push the minimum wage up, it's going to create a larger surplus of workers. And so you're going to only have, let's say, 1,500, and you're going to have 9,000. And so it's going to, the higher you push the minimum wage up, the greater the surplus of workers, the fewer the jobs that are available, the more workers that are going to be laid off as opposed to the lower equilibrium wage. What if, for example, if we erase this stuff, what if they set a minimum wage at a price that is lower than equilibrium? So let's say, for example, that this is in, let me start over here. Let's say this is like a highly skilled technical job. So let's call this $20 an hour, 40, 60, 80, 100, and $120 an hour. Ignore this one for a second. And so let's say equilibrium wages in this market are right now $50 an hour. So let's call this nursing. So a lot of times nurses get paid pretty high dollars per hour. So let's say nurses are getting paid $50 an hour, and the government comes in and sets the $7.25 minimum wage that we talked about. What is this $7.25 minimum wage? How does that impact nurses? Well, it doesn't impact them at all, right? Again, ignore this one for right now. The $7.25 doesn't do anything because the wages are currently set at $50 an hour. So it doesn't create, because this, right, if you said, oh, it creates a huge shortage, right, the quantity demanded is here and the quantity supplied is here, that would be wrong because this is not a price ceiling, it's a price floor. So this is the minimum for this market. Well, they're already, businesses, hospitals are already paying their nurses $50 an hour. So setting a minimum at $7.25 it's not going to have any impact on the market at all. All right. So a binding or an effective minimum wage is going to go above. So if they were to say, oh, you have to pay your nurses $65 an hour, that's going to have an impact, kind of like what we showed with minimum wage in a fast food industry, let's say, in the last example. All right. These are just two terms that we should probably already know. But as it talks about physical capital and human capital, it's important to understand that physical capital are physical things, the tools needed to produce stuff, and human capital is our knowledge or our experience. And so as we talk about certain factors of production, it's important to keep in mind what we mean by physical and human capital. Capital isn't like investment in a stock. Capital is what we use to produce other things. And so when we talk about human capital or physical capital, it's the tools, resources, or knowledge that we use to produce something. That's the capital that we're talking about when we mention that in these factors of production. All right, so here's where it gets a little bit tricky and a little bit more involved, not just simple supply and demand. So this is where we're going to have to make sure we understand the terms that we're using and the concepts that we're talking about, because we're going to put some numbers in here and some new terms that we're not familiar with. But ultimately, what we're trying to understand or trying to show is that we assess things marginally. All right. And so if you look at these two things that I just highlighted, simply what these two things are marginal revenue and marginal cost. That should be familiar to us. That should be nothing new. As we look at these two things, we're just looking at marginal revenue or the extra benefit and marginal cost or extra cost. So not that long ago, we continually assess it like this. But we did something like this where we had Mr. DARP, and that would be our marginal revenue curve, and then we had like a marginal cost curve like this, right? So extra benefit, extra cost, profit maximizing is going to be right there. So that rule, that's never going to go away, that idea or that rule. So now we're talking about hiring workers, and we want to know, well, what's the extra revenue that they generate, and what's the extra cost for hiring them? And we're going to assume that we're going to try to continue to hire until these two things are equal to each other. All right. So if I just kind of slow down for a second and point out a few things, it says a firm is willing to hire a worker when the worker increases the firm's revenue more than the firm's cost. So the point of this point, like bullet point, is it worth it to hire that worker, right? So I was talking about like making a trade, right? So if I get $10. If the worker generates $10 and I have to pay them $7.25, is it worth it to hire that worker? Well, yeah, that's definitely worth it to hire that worker. What if a worker generates $5 and I have to pay him $7.25? Is it worth it to hire that worker? It's not, right? The worker only generates $5 an hour and I'm paying him $7.25. That's charity. That's not like how a business works, right? They don't hire people that can't generate as much as I have to pay them. So a firm is willing to hire the worker as long as this is true. They generate more than it costs me to hire them. And so we're going to look at these two kind of concepts of marginal revenue product, or how much revenue is generated by a worker, and we're going to compare that to the marginal factor or resource cost, which is how much it costs me to get that worker. Right, so if you look at kind of the definitions here, it says the increase in revenue created by hiring an additional worker is called the marginal revenue product. So we're going to use that term, MRP, marginal revenue product, how much revenue is generated by additional products created by another worker. I'm going to pause for a second in case you need to write that down. And I'm going to compare that to the marginal factor cost, or MFC, which is how much does it cost me to hire that additional worker. It says the increase in costs from hiring an additional worker is for a competitive firm is simply the worker's wage. Right? So this is just going to be the wage I have to pay, and this one is going to be how much revenue does that worker generate. So again, I'm just comparing marginal benefits to marginal costs. Or really simply, if they generate 10 and I pay them their wage of $7.25, is it worth it? And so we're going to just basically kind of show in numbers and graph and kind of fully understand and assess this. So I'm just going to wait for a second. You can write anything further down, but this is a very important kind of key slide to understand those two terms. So MRP, MFC, those two things you should write down a bunch of times in your notes and define. If you have those two definitions right there, that would be very essential. All right, so here's where we get it to understand it with the numbers. All right, so this one we're going to just basically look at this idea of marginal revenue product. And again, this nothing right here should be that extraordinary to us or that brand new to us. But if I highlight a few things, I'll just kind of show you the different columns of what we're really looking at right here. So if we look at this column in red right here, all that column is showing is the workers that I hire, right? So I can hire, one worker, 2, 3, 4, 5, 6, 7, 8, right? And so I hire more workers. What's this next one showing, right? What's the green column showing? Well, the green column is showing what's my output I get. What's my total output when I have 1 worker, 2 worker, 3, 4, 5 workers, 6 workers, 7 workers, 8 workers, right? So this green column is just showing my total output or total product, right? So what's my total product when I have 6 workers? Well, it is what it is. It's 84, right? So then I want to know like how much extra output I get from 1 more worker, okay? And so we've done all this, right? We've done this in the past. So just kind of a quick, what does this look like? Remember we talked about how we have this total product curve that goes something like that, total product, right? So this is output or quantity of output, and this is quantity of workers. And so when I hire 1, 2, 3, 4, 5, my total output goes up really fast, goes up a little bit slower, eventually hits a peak and goes back down. We did paper chains for that example in class, and we talked about it last Friday. So then what the other one is showing, the marginal revenue product, the marginal product of labor. Again, we've done that. We talked about increasing returns, diminishing returns and negative returns. And so what that is simply doing is kind of showing these three phases of the returns to labor. And so marginal is going up when the total is increasing really fast. Marginal is going down but positive when the total is increasing by less and less. And then marginal is negative when total product is decreasing. That's just review. That should be nothing new to us. So going through and finding these things should be nothing new to us, right? So this column right here shouldn't be anything new to us. It's just shown one more time. So this should be old for us. This should be old review for us. So how do I find, well, what's the extra product I get from the sixth worker? Well, I look at what the fifth worker gave me compared to what five workers gave me compared to what six workers give me, right? And so that sixth worker helped generate an extra 9 units of output, right? So if I go through each one of these, hiring the first worker gave me an extra 19, hiring the second worker gave me an extra 17, hiring the third worker gave me an extra 15, 13, 11, 9, 7, and 5. So hopefully we can kind of see and understand what's taking place right there. Okay, so the reason why we have this slide right here is to basically show how we take this concept right here, this column, and we add details in order to figure out, well, is it worth it to hire that worker? Or I want to know on this slide, what's the marginal revenue product, right? So if I have marginal product right here, I want to know what's the marginal revenue, or what's the extra revenue I get from one more worker. So in order to do that, I need to know, one, the price of the good, and then how many units of output that person can generate. And so we did this on Friday, but if we just look again, right, this first worker can generate 19 units of output. What do I do with those units of output? Well, I sell them. I sell them at $2 each, right? So the $2 is right over here. And if I sell each one of those for $2 each, I can get $38. So this first worker helps generate 19 units of output. I can sell those 19 units for $2 each. That means that first worker generates an extra $38 compared to not having that worker. I hire the worker, I get an extra $38 because they can produce 19 units of output. I sell each one of them from $2 each.
So, really quick story. I recorded 27 minutes this morning at school. Came home, recorded another about 30 minutes, and then the app crashed and I lost all of the stuff that I did at home. So, that's why I have a quick story right here, because I just spent the last 35 minutes recording a video that I don't have anymore. So, that's how frustrated I am right now. So this is going to be a very shortened version of that, and I'm going to do something a little bit different instead of going through everything. So lucky for you, it's going to be a lot shorter than my first video. So let me finish my thought right here, and then I'll get a different, I'll kind of explain it hopefully in an easier and simple process instead of me droning on for so long. But what we'll do to finish up this one, this slide, is to kind of finish out the thought, is that each of these workers is going to generate X amount of output, right? Extra output, extra output, extra output. And all I want to do is I want to say, well, how much revenue is that? And I can take that times how much I can sell each one of those units of output for, right? So that first worker helps generate 19 units of output. I can sell each one of them at $2. Therefore, that worker generates $38 of output. The concept should be pretty straightforward and simple for us. Because of diminishing returns, the second worker can only generate 17 units of output. But I take those 17, I sell each one of them by $2, and I get $34 from that worker. That worker helps generate an additional $34. This worker is 30. This worker is 26, 22, 18, 14, and 10, right? So each worker generates less and less revenue because of diminishing returns to labor. As I add workers to some sort of a fixed space, I get less out of each worker. So we're kind of combining a lot of concepts here. The concepts themselves aren't that difficult, but combining them all together is what makes it difficult. Make sure in your notes somewhere you get this formula down right here. The marginal revenue product is generated by taking the price of the products that I sell times the extra output I get from each additional worker. So these are going to be two important components. And changing either one of these two things is going to change my marginal revenue product. So if I change my marginal product of labor, in other words, let's say I get more tools or more technology, I might be able to change my output I get per worker, and that's going to change my marginal revenue product. If I change the price of the goods I can sell, right? So if this goes up to, let's say, $3, that's going to change my marginal revenue product, because I take each one of these then times 3, and each worker can generate more output than they could before. So if we just show this one graphically, it should be hopefully pretty straightforward for us. If we take this idea of the marginal product of labor, and we see the marginal product of labor diminishing like this, my marginal product of labor, in order to figure out the marginal revenue product, I'm simply taking each one of these things, and I'm taking it times the price. And so it's going to be the same curve, basically, just increase. So just for a moment, let me do it in red. Let's say this is that marginal product of labor line. I just take each one of those points and I take it times the price, and that's going to move it up by whatever that is, right? So if it's times 2, it just doubles each one of them. And so my marginal revenue product is going to be the same shape. It's just going to be up higher, marginal revenue product. And this becomes my demand curve. I demand workers based upon how much revenue each worker can generate. Well, how do I know what the supply of workers is? Well, the supply of workers is going to be determined by the wage I can pay the workers, right? So at a certain wage, I'm going to have X amount of workers that want to work at that wage. And so we'll talk about kind of what that looks like with an example. So instead of doing what I had done before, I'm going to do, hopefully this a little bit different. I'm going to use 2 examples to try and explain a bunch of the stuff from this unit. So we're going to use this free response to try and explain what this idea of side-by-side graph looks like and what the market and the firm is. And so we'll do the same things, we'll just use the examples to do it to cut down on some of the time. So take a look at this one. It says the John Lamb Company, a profit-maximizing firm producing widgets, is in a perfectly competitive widget market. Assume John Lamb employs a fixed number of employees and rents a machine for a variable number of hours from a perfectly competitive market. So it's talking about kind of 2 things here. It's talking about a profit-maximizing firm basically selling these things in a perfectly competitive product market. And then it says it employs and rents a machine for a variable number of hours, employs a fixed number of employees, and rents a machine for a variable number of hours from a perfectly competitive market. So this is a second perfectly competitive market. This is a perfectly competitive factor market. So we set that idea up before at the beginning with that circular flow model that existed, and we had exchanges kind of between these different things. And one half was the product market where people are buying and firms are selling, and one is the factor market where people are selling and firms are buying. And so just as a kind of a real quick reminder, we want to take a look at and remind ourselves what the product market looks like, what the perfectly competitive product market looks like, and then we'll use that to set up what this idea of the perfectly competitive factor market. Because we know this should be pretty easy for us. And so I'm going to go over here and just remind ourselves what a perfectly competitive product market looks like. So the perfectly competitive product market has an upward sloping supply curve for the market and a downward sloping demand curve for the market. Remember, this is the entire market. So this is everybody. This is all buyers and all sellers. The price is determined by the equilibrium in the market. And then we have the individual. I don't have the greatest setup. Let me move over just a second. Then we have the individual firm. And how's the individual firm impacted by the market? Well, they take this price that's set by the market, and then they can sell as many as they want at that. So there's really an infinite demand or a perfectly elastic demand curve for individual firms selling goods within this market. And then we have an upward sloping supply curve or marginal cost curve. The other thing that we noted is this demand curve used at the price right here is Mr. DARP. And Mr. DARP represents the marginal revenue, the demand, the average revenue, the price for this. And so this is a perfectly competitive profit maximizing firm. So they produce where MR equals MC. So this is just a reminder, and hopefully remember some of the basics about why it is the way that it is, why the market has a certain influence on the individual firm, how things that change in the market will impact the firm. So if there's an increase in demand, right, price is going to increase. Price will increase over here. They'd take a higher price, and then they would adjust, and they'd be able to sell more products. And that hopefully makes sense to us, or hopefully remember a little bit of that. Now what we're trying to learn and trying to look at is this idea of the perfectly competitive factor market. So we're going to have obviously some of the same concepts. We're going to have a market. We're going to have an individual firm. We're going to have the market determine certain things. We're going to have firms basically take that what's determined by the individual firm. So in this one, this idea is, it says, using a correctly labeled side-by-side graph of the factor market, right? So we want to make sure that we, in our mind, or at least on here, we want to make sure that we highlight that we're talking about the factor market. So if you were to go ahead and graph the perfectly competitive product market, that would be wrong because it's asking you to graph the factor market. It also tells us directly right here to show the side-by-side graphs of the factor market for machines and John Lamb's company. Show each of the following. So it asked me to show this. So in this one, we're going to show this one over here, and we're going to try to compare it to the perfectly competitive product market. So let me see if I can shrink this down. So I'm going to leave the product market there, and we're going to try to show this perfectly competitive factor market. So just like we've done, when it's perfectly competitive, you have this entire market that determines much of everything for the individual firm. So in this context, we've done this before. We did this the first day that we got together, and we said, well, this supply curve is no longer firms. This is actually individuals that are supplying their labor. And so this represents basically the wage in which workers will work. And so at a higher wage, more workers will want to work. At a lower wage, fewer workers want to work. This is the demand for workers, and this is a firm's demand for workers. And at a high wage, they can't afford, or they don't want to hire very many people, and at a very low wage, they'd like to hire a lot. Well, the interaction between these two things, between firms demanding workers and the supply of workers, you're going to get the equilibrium wage and quantity of workers. So this is wage, and this is quantity of workers. Now the firm is going to have to take what the market sets. So this is the market, and the firm is going to be what we call a wage taker. All right, so this is going to be our firm over here. This is the individual firm, and they take the wage that's set by the market. All right, so this is going to be our individual firm right here. They have to take that wage, so they are wage takers. Right, so McDonald's, right? So there's an entire market for fast food employees, and McDonald's. You know, they could set a higher wage, but this is basically the wage that they set, and this becomes the supply curve, or what we're going to call it the marginal factor cost. And what the marginal factor cost is basically the marginal cost for a factor of production, and in this case it would be a worker, and in this case it would be the wage for that worker. All right, so the firm, they're wage takers. They take the wage that's set by the market. The last thing that we want to add is the thing that we just learned about a little bit ago, which is the marginal revenue product. So the marginal revenue product, I'll do a different color so we can see it. The marginal revenue product, remember, it's derived from the price I can sell the good at up here times the extra output I get from each individual worker. So a higher worker, I get 10 extra. Hire another worker, I get 8 extra. Hire another worker, I get 4 extra. And then I take that times the price I can sell each one at, and I have this downward sloping demand curve, or we'll call it the marginal revenue product. And again, the idea is, and it's pretty simple, we've done it a bunch of times, is if the extra revenue that this worker generates is up here, and I have to pay them this right here. So for example, generates $10 of output, and I have to pay them $7.25. Should I hire them? Well, yes, I should, obviously. If they generate $10 and I only have to pay them $7.25, I'm going to hire. What about if they generate $8 and I pay them $7.25? Well, yeah, I hire them. Well, what about if they generate $5 and I have to pay them $7.25? Well, no, I don't hire them. So I stop right there where the MRP equals the MFC. That's my profit maximizing number of workers that I should hire. So if we go back to our main question and we kind of roll through what it asked me, did I do everything, right? So it says correctly labeled side by side. I did my correctly labeled side by side. It asks for the rental price. The rental price in this context would be the same as the wage. I was just talking about hiring workers, and it's talking about renting machines, but it's the same idea. The rental rate is going to be the same right there. That's determined by the market. And then it asks for the quantity that this firm should hire, and that would be this QM right here. And so that would be the quantity of either machines or workers or whatever it is. It would be MRP equals MFC. Okay, so let's go back over here and we'll take a look at the second one. Now the second one is talking about something that's brand new to us, and so this might be slightly confusing, but I think the idea is pretty straightforward. So if we look at B, it says assume the popularity of widgets declines, decreasing demand for widgets. Now hopefully you're thinking of, well, that's product market, not factor market. What will happen to each of the following? The marginal product curve for machine hours, the marginal revenue product curve for machine hours, and explain. So this one we're saying, well, something's changing in the product market. How does that impact the factor market? Well, that's an important concept. And what it's called actually is called derived demand. And this is a perfect example to try and explain this one. What would you say if the demand for Rubik's Cubes increased? What would happen to the number of workers that we would need for Rubik's Cubes? Well, if Rubik's Cubes became hugely popular, what do you think would happen to the demand for workers that make those? Well, you're going to assume the demand for them goes up. Well, why does it go up? And how do we show that it goes up? Well, the idea is that the demand for workers is derived from the demand for the good that they make. So if there's no demand for Rubik's Cubes, nobody wants a Rubik's Cube, what do you think happens to the demand for the workers that make them? Well, it goes down by a lot. Why does it go down by a lot? And it goes down by a lot because of the marginal revenue product. Or, again, it's the revenue that each worker generates. All right, so when the workers generate a certain amount of money, that's how I figure out how many I can hire based upon the wage that's set in the market for workers. So what happens to the price of widgets when the demand for widgets goes down? Well, when the demand for widgets goes down, the price for widgets goes down. And so the MRP is going to decrease. And it's going to decrease because each worker generates less revenue than they did before, because the price of the products that they are creating is decreasing. And so I'm not going to hire as many workers as I did before. So what does that look like? If we go back over to this one, right over here, we can show that one. Well, let me actually just start anew for a second. We can show that by doing something like this. If this is my marginal revenue product, and let's say this one, just for example, each good that I sell is $2. Well, if that price is cut to $1, it's just like we were doing before. If the price is cut, then the revenue that each worker is cut. So this worker could generate, let's say, $20 before. Well, so if the price is cut in half, let's say they can only generate $10 now. And before, this worker could generate 18, and now they can only generate 9. So it's down here. And that would take place for each point along here. So this demand curve, this marginal revenue product line, would decrease like this at each point. And they would basically be the same. My lines aren't perfect, but it would just shift that whole thing down. Well, let's say before the wage was right here. When I had this greater MRP, I hired that amount of workers. But if the extra revenue that each worker generates goes down, then these workers are no longer profitable, and I'm only going to hire that amount right there. So what's changing is not the marginal product of labor, but what's changing is the price. Remember, those two things make up the MRP curve. And so that idea is going to help us answer these questions right up here. So let's look at this one. It says, assume the popularity of widgets declines, decrease in the demand for widgets. What will happen to each of the following? Well, what happens to the marginal product curve for machine hours? What happens to the marginal product of machines or marginal product of labor? What happens to that? Well, hopefully somebody in the room is answering nothing. Why nothing? Because it doesn't change how much each worker can produce. It doesn't change that. It doesn't change the marginal product. So the price of the good doesn't change the marginal product of labor or the marginal product of machines. What does it change? It changes the marginal revenue product curve. And what's going to happen to it? It will decrease. Why does it decrease? Well, one of the reasons why it decreases is because it's a derived demand. You could also use MRP times P to, sorry, not MRP times P, marginal product of labor. Marginal product of labor times P equals MRP to help explain. So if the marginal product isn't changing, but the price is changing, that's going to change the marginal revenue product. Okay, let's go to the very last one right here. Let's see if we can figure this out. It says John Lamb is employing the cost minimizing combination of outputs. New concept, we don't know what it is. Cost minimizing combination of inputs. The marginal product of labor is 28 widgets per worker hour, and the wage rate is $14 per hour. The marginal product of the machine is 60 widgets per hour. What is the hourly rental price of a machine? All right, well, how would we figure this out? We don't know what we're doing. How would we figure it out? So we're going to look at it like this. I have two things I can employ, right? I can employ a machine or I can employ a human being. Well, which one of these two things is faster at producing something? Well, if we look at this, the machine can produce 60 widgets per hour, and a person can produce 28 widgets per hour. So I can get 60 per hour, or I can get 28 per hour. All right? Well, in this context, well, obviously I should get the machine. I should hire the machine. Well, but it actually depends, right? It depends. Well, what if I only had to pay this person, let's say $5, but I had to pay this machine $500? Now which one should I hire? Well, hopefully in that context, it's pretty easy. I should hire the person. I could hire 100 people before it would be worth it to start to hire that machine. And so it depends on how much I have to pay in order to get that worker. And so if we were to look at this, they tell me he's employing the least cost, the cost minimizing or least cost combination of inputs. And it actually tells me that the wage rate is 14 per hour. So I'm getting 28 and I'm paying 14, which means I'm getting 2 basically per dollar. Right? I'm getting 2 units of output per dollar. Well, what in order for these two things to be equal, what would I get per, what would I have to pay per machine hour? Well, in order to get these two things to be equal, I'd have to pay $30 per machine hour, and therefore I would get 2 per dollar right here, and those two things would be equal. Why do they have to be equal? Well, because let's say they're not for a second. Let's say that this was actually, let's say this was 10, right? And I would not be cost minimizing, because what I could do in this context is I could fire some people and hire machines instead, because here I'm only get 2 units of output per worker, and here I would get 6 units of output per worker. And so it would be worth it for me to fire a few people and hire some more machines. Remember, as I hire machines, what happens to my marginal product? Well, the marginal product, or this top number, is going to start to decline. And so if, let's say I hire one more machine, this might drop to 50 over 10. Hire another one, it might drop to 40 over 10. Hire another one, it might drop to 30 over 10. Hire another one, it might drop to 20 over 10. And then I'm back to having them kind of be equal to each other. So what I want to do is I want to employ, as long as the rental rate, sorry, not rental rate, hold on a second. I want to employ, as long as the marginal product for the machine over the rental rate is equal to the marginal product of labor over the wage. So this becomes my least cost, or cost minimizing combination. Typically you don't have to derive all of that, but it's pretty easy from the example to see the hourly rental price of a machine should be $30 per hour for that to be the case. Okay, we're going to do one more example and then we'll be done. So we should be done hopefully a couple minutes early. But what I would like, and with that time, I would like you to work on the problem set that you have. And so again, you should do the first 3 problems for Thursday. So this one, I just want you to pause the video. You can leave this up here. I would like you to work on this one. I would like you to complete this one. I would like it to take you about 10 minutes to work on and complete. Double check with people that you're next to, that you're by. Shouldn't be any brand new concepts right here. It's a pretty straightforward one, pretty commonly found one, and one that I would expect you to be able to go through A through E and get them all correct and be very confident with it. So don't rush through it. Do each one of them and check each one of them, and in about 10 minutes you should be able to play the video and I'll go through the answers. Okay, hopefully it went well. For this one, it gives you the chart. It even gives you marginal revenue product per day and number of workers. And so in the back of our head, it should look something like this. I have the demand curve, or the marginal revenue product is there. Sorry, that didn't do what I wanted to. But I have my marginal revenue product, or my downward sloping demand curve. This is my demand curve. Right, so this is price and quantity, and this is the curve that I have right there. So let's kind of roll through this one and see what we got right or got wrong. It says the table above gives the short run marginal revenue product of labor per day for a perfectly competitive firm. So we want to make sure that we underline that perfectly competitive part. The firm is currently selling its product at a market price of $5. We want to make sure that we circle that one. So this is the product market information right here. So in the product market, we'd have a supply and demand for our good, and this would be the price and quantity. $5 is the price. It says calculate the marginal physical product of the third worker. This is sort of tricky. It's asking us to work backwards a little bit, right? So I have the marginal revenue product per day. It's asking for the marginal physical product of the 5th worker. Now, marginal physical product could be slightly difficult, but it says marginal product. Marginal physical product, marginal product. It's the marginal product of labor for the 5th worker. All right. So how do I know how much output, how much additional output did that worker generate? Well, in order to calculate this column, I would take the marginal product of labor times the price of the good. That equals 300, right? And so I'm looking for marginal product of labor. I have price, I have marginal revenue product. So marginal product of labor times 5 equals 300. So the marginal product of labor must be, anybody? 60. All right, so my marginal product of labor for the third worker must be 60. All right, next one. Define the law of diminishing marginal returns and explain why it occurs. I love questions like this. They're very easy, yet lots of other people get them wrong because they're kind of sloppy with their terminology. Easy question though. What's the law of diminishing marginal returns? Explain why it occurs. They may remember what example we used in class to try and show it. Well, the example that we used in class to try and show it were paper chains, right? We made paper chains. And what happened? We hired a worker, made paper chains. Hired another worker, made paper chains. Hired another worker, made paper chains. But what happened is we continued to add workers to our fixed jobs and fixed space. We got less and less extra output from each additional workers. So the law of diminishing marginal returns is the law that exists, or the fact that I'm going to get less extra output from each additional worker that I hire. I get fewer returns from each extra worker that I hire. Why does it occur? Because I'm adding variable inputs to some sort of fixed input or fixed space. All right, so that I'm not going to write all that out, but those are my definitions and explanations for it. C, diminishing marginal returns first occur with the hiring of which worker for the firm, right? So when do I first experience diminishing returns? So I could go and I could divide each one of these by 5, but that's not really necessary. I could just kind of see when diminishing returns actually takes place. And so I would notice in this one my returns go up, right? And then my returns go down. And so I hire worker 1, it's not that. I hire worker 2, I actually get more output from worker 2. I hire worker 3, and I start to experience diminishing returns. So it should be the third worker. What is the highest daily wage that the firm is willing to pay to hire the fifth worker? All right, so the fifth worker brings us back to the fifth worker. Oh, I'm sorry. I noticed I made a mistake. Because here it asked me about the third worker. People were probably trying to yell at me before. Now I'm not going to go back and reshoot all that, but obviously I did make a mistake. That's why I paused here for a second. All right. So this one was asking about the third worker. So it doesn't equal 300. I'm not sure why I was looking at that. Maybe because the price is 5. The third worker, it generates 450. 450. So what would that be? That would be 90. All right, so this isn't 60. This is 90. Okay, you can stop yelling at me now. I hopefully fixed it. Sorry about that. And so this worker is asking me about the fifth worker. What is the highest daily wage that the firm is willing to pay to hire the fifth worker? Well, how much do they get from hiring that fifth worker? Well, they get $300. So would they pay 305? Would they pay 500? Would they pay 190? Well, yeah, they'd be happy to pay 190. They get 300. But they wouldn't pay 305. They only get 300. So the absolute highest, you could put 299.9999999, or typically what we do is we just make them equal to each other. All right? So the highest they'd be willing to pay to get that worker is $300, because that worker generates an extra $300. Okay, last one. Last one. What will happen to the demand for labor? What will happen to this, right? The demand for labor, right here. If the market price of the product increases, here's an explain. All right, so hopefully this one we got. This is supposed to be the hardest one of this problem. So what will happen to the demand for labor if the market price of the product increases? What's going to happen to the workers I need if there's a greater demand for the products that they sell? Well, I'm going to need more workers. But what's my explain for this one? And my explain is because this is a derived demand. My explain is also that the marginal revenue product is created by taking the price of the good times the marginal product of labor. So if this price were to increase, that means that the amount of revenue that each worker generates is also going to increase, which means I can hire more workers before I get equal to the MRP equaling the MFC. Or if, let's say, before that the MRP of the last worker, let's just say, was 10, right? And I hired them at a wage of 10. Well, and now if the price increases, let's say that last worker now can generate 20. Well, not only can I hire this worker that generates 20, but I can hire the worker that now generates 15, and I can hire the worker that now generates 10. Whereas before, this worker might have only generated 5, and this worker, or 7, and this worker might have only generated 5. But I can hire those workers now since they're producing more revenue for each worker. Okay, I know that was kind of long, drawn out. It took me a lot longer than I wanted to create and go through all that since I lost about 30 minutes of it. You have time right now to work on some stuff. You should definitely work on the first 3 problems of the problem set. Not really a suggestion, more of a requirement since you have some time here. We don't have a lot of days to cover stuff, so when we come back on Thursday, it's going to be rapid fire, because then we're going to go into Easter break, and we come back on Tuesday. We're supposed to have a test on that day. I think it's Tuesday. Whatever day that we're first together again, when we come back from Easter, we're supposed to have a test on that day. And we might be able to review a little bit at the beginning of class, but Thursday is going to be our main day together this Thursday. And so we're going to have to cover a lot of stuff, practice a lot of stuff. So it's very important that you work on your problem set. You get 1, 2, and 3 done for Thursday. All right, we'll see you then.